Hello, I'm hoping you've had time to go over this application bearing problem. Let's look at it together and see how you did. Example 10 on page 132 in your note guide. A plane flies due east at 500 kilometers per hour, and there is a 60 kilometer per hour wind blowing from the southwest with a bearing of 45 degrees. Find the ground speed and the actual bearing of the plane. Solve in two different ways. So the first way we're going to solve, let's go ahead and draw this. So our plane, it says, is flying east. And so we're going to draw this plane going east. And the magnitude of that vector is going to be 500. And then it says that we have a wind. And if the wind is blowing from the southwest, south is down here, and west is over here. So here's south and here's west. So the wind is going to be blowing in this direction. And it says it has a bearing of 45 degrees. And it's going 60 kilometers per hour. You can see I've labeled the magnitude of the plane. This is 500, and the magnitude of the wind, which is 60 kilometers per hour. I just want to remind you about a bearing. A bearing always starts north and goes in this direction. So that angle right there is your 45-degree bearing. So you can see I've drawn a parallelogram. This diagonal line is the resultant force. So the first thing we're going to do is label the angles of our parallelogram. So starting here, we know that this angle here is 45 degrees because 45 plus 45 bearing gives you 90. In a parallelogram, this angle is going to be the same. So it's also 45 degrees. We know that the four angles add up to 360. So we take 360, we subtract the 90, and then we divide that by 2. And that's going to give us 135 degrees for that angle and 135 degrees for the angle across from it. So now what we're going to use is side angle side to find the resultant. So we're looking for this diagonal line. We know that this side of the parallelogram is also 500. So we have 60 as a side, we have the angle of 135, and we have 500 as a side. So let's go ahead and figure out what the resultant is. So the resultant is going to be law of cosines. We're going to do the square root of, and then we have 60 squared plus 500 squared, subtract 2 times 60 times 500, cosine of 135 degrees. You're going to make sure that your calculator is in degree mode. You're going to throw that all into your calculator, and you're going to end up getting 544.083 kilometers per hour. Now that we've found the ground speed, we're going to find the actual bearing of the plane. So where is the plane after the wind blows it? So let's put in the ground speed is right here. It's 544.083. I recommend storing that number so that you're using the full number in the story problem. Okay, so the next thing we're going to do is figure out the directional angle. That's going to be this angle right there. So in order to find that angle, we can go ahead and use the law of sines. We know that the sine of theta over, and then we know that this side of the parallelogram is 60. So we can do the sine of theta over 60 is equal to the sine of 135 degrees over 544.083. Use the full number. So you can cross multiply, and then you can solve for the sine of or you can solve for theta. So that's going to end up giving you theta is equal to 4.472 degrees. Now the question asked us for the bearing. It didn't ask us for the directional angle. This is the directional angle. So what is the bearing in this problem? The bearing starts north and it goes to where the resultant is, which is that pink angle right there. So in order to find the bearing, you are going to take 90 degrees. Oh, that doesn't look good. Hold on. Let me try again. So in order to find the bearing, you're going to take 90 degrees and subtract theta. And you know theta is 4.472 degrees. And that's going to give us this bearing right here. So 90 degrees subtract theta will give you the bearing. So you can see our answer for the bearing is 85.528. And that's north going in a clockwise direction. And then the actual ground speed of the plane is 544.083 kilometers per hour. Now we have the same problem, but we're going to do it a different way. This time we're going to solve the problem by adding vectors. So the plane vector, how you write a vector in component form is you do the magnitude, which is 500, and it would be the cosine of 0 degrees. And the reason why it's 0 degrees is because the plane, the directional angle is 0. It's going east. And then you would put the magnitude, which is 500, and the sine of 0 degrees. The wind vector, again, the magnitude of the wind is 60 kilometers per hour. So that's going to be 60 cosine. And you want the directional angle of the wind. So that's that angle right there. So the directional angle is 45 degrees. Do not use bearings when you're adding vectors. And then you've got 60 and sine of 45 degrees. In your calculator, you'll do 500 times the cosine of 0 plus 60 times the cosine of 45. And you're going to get this result of the two vectors added together. This is 542.426. Now what I recommend is go ahead and store that as A. Then you'll put into your calculator 500 sine of 0 degrees plus 60 sine of 45 degrees. After you put that in, you're going to get 42.426. And put that into your calculator, store it as B. So you can see that the result vector I drew right here and highlighted. So that's the result that I get. Now to find the length of that vector, do you see how I have a right triangle? So the magnitude is the actual length of the result. So to find the length of the result, I'm actually going to need to find the magnitude of the result. So the magnitude is going to be Pythagorean. You've got A right here, and you've got B right here. And so you can simply put in the square root of A squared plus B squared, and that's going to give you the actual magnitude. So the actual magnitude of the plane is the same as it was in the other problem. It's 544.083 kilometers per hour. I want to point out the reason why I highlighted these angles is it's really important that you never put bearings into vectors. You always want to put the directional angle in when you use the angle to write the vector in component form. So the next thing we need to do is we need to figure out how we're going to find the direction of the plane. The directional angle is that angle right there. So you can see that we can use tangent. I have the opposite. I know what B is. It's 42.426. And I know what A is. It's 542.426. All right. So what we're going to do then is the tangent of theta then will be B over A. That means theta is going to be the inverse tan of B over A. So if you've stored B and you've stored A, then you can put those into your calculator and you can figure out what theta is. So theta right here ends up being 4.472 degrees. Again, the problem didn't ask for theta. It asked for the actual bearing. And bearing always starts north and goes in this clockwise direction. So how do you find this angle? Well, the full angle is 90 degrees. Take away theta. So if you take 90 and you subtract theta, that's going to give you the actual bearing. Okay, so hopefully you didn't hear TJ in that clip. Anyway, this is going to be the bearing, 85.528, and the speed of the plane is 544.083. So you can see that the plane was flying 500. Have you ever been on an airplane before and you end up getting there early because the pilot says there's a tailwind and the plane's getting pushed faster? This is what's happening in this story problem. So with the wind behind the plane, it's actually making the plane go faster. Instead of 500, it's going 544. And then the wind is also blowing the plane off course. So instead of it going directly east, it's actually 4 degrees off of going directly east. So now I'm going to give you some story problems. I'd like you to try these story problems at home tonight. And then we have a Zoom tomorrow that you can ask questions on the assigned homework. So thanks. Have a great day, and I will see you tomorrow.